The best way to start the lesson about functions is to take the arrow diagram of a relation. So let's say we have the two sets. In the first set, we have the numbers 1, 2, and 3. In the second set, let's say we have A and B. The relation name is F between the two sets, and is defined as the following. This relation is said to be function when every element in the first set is paired with exactly one element in the second set. The first set is called the domain, and the second one is called the range. And the elements in the domain are said to be independent, and in the range are said to be dependent. The elements in the first set are said to be X, and in the second set said to be Y. If I want to find f of 1, meaning the element 1 is paired to which element in the second set, that's A. It's very important to note that this element is in X and this element is in Y. If you have an element in the set A that is not paired with any element, then this is not a function. Or if you have an element, let's say 1, paired with more than one element, then it's not also a function. I have prepared some questions. Hopefully they will help. The first question we have, the graph of a function f, state the value of f of 1. Graphically, how to find the image, or to which number or to which element the number 1 is paired. So what we do is, for x equal 1, we make a vertical line and see where it crosses the function f, the blue graph. I see it crosses here. So the element in the y is 3. Part B, estimate the value of f of negative 1. So for x equal negative 1, this is x equal negative 1. We do vertical line. It crosses the blue graph here, and the value corresponding to y is almost here, like negative 0.2. The third one, for what values of x is f of x equal to 1? Meaning, find x when y is equal to 1. So on the y-axis, we do horizontal line, not vertical line, and see it crosses the graph in two places, here and here. So we need to find the corresponding value along x. So the corresponding value of this is 0, and the corresponding value of this is 3. So x could be 0 or x could be 3. Part D, estimate the value of x such that f of x equal to 0. The same thing, y is equal to 0. So this is y equal to 0. We make a horizontal line. It crosses the blue one here. And the x value here is almost 0.6, negative 0.6. Part E, state the domain and range of f. A domain is defined as the set of values of x. The starting of this graph is here and it ends here. So the value here is -2 and the value here is along the x-axis is 4. So the domain is defined as closed interval from -2 to 4. And the range is on the y-axis, the starting is here and it ends here. Or the lowest value is -1 and the highest value is 3. So range is closed interval also from -1 to 3. On what interval is f increasing? Scanning from left to right, the graph starts from here. It shows going up until this point, so the graph is increasing and the value is taken along the x-axis from -2 and it ends here, so from -2 to 1. Here's the discussion. Some they write as closed interval from -2 to 1. Some they take it as open interval from -2 to 1. This depends on your teacher or on the book you are using. We're gonna assume closed interval. And the common question, determine whether the curve of the graph is a function of x. Determine whether the curve is the graph of a function. Graphically, to know it is function or not, we do a vertical line at every position. If it cuts in more than one place, then it's not a function. I see it cuts in more than one place in some places, so this is not. The other one, all the vertical lines, they cut in one place. So this is a function, and we're gonna find domain and range. The domain along the x-axis from -2 to 2. And the range scan along the y-axis. The lowest is here and the highest is here. So from -1 to 2. The third one, also I see the graph, the vertical lines, they cut in one place. even here because this is filled and this is empty, so consider it cuts in one place. So yes, it is a function to find the domain and range. A domain scanning from left to right. It starts here, -3, and it ends here, 2. So domain from -3 to 2. Range, here I see we have jump or gap between the graphs. So if we do scanning from down to up, the lowest is here and the first part ends here. So range is about -3 to -2. The circle is empty here, so open interval. And the second one, the second part is from here, -1. So it's closed interval, -1. And the highest is here, which is 3. Also closed interval. The last one, since I can find this vertical line cuts in more than one place, then it's not a function. How to find the domain if we have the equation? We just need to find the values of the denominators, or to solve the denominator, so x squared minus 9 is equal to 0. With any way, square root, quadratic formula, even calculator mode 5-3, we're gonna find x equal plus or minus 3. Meaning the domain is R, all the real numbers except these two values. Another way to express the domain is on the number line from -infinity to +infinity. And we have -3, +3. We can see we have 3 intervals, 1, 2, and 3. So we write the domain as -infinity to -3, union -3 to 3, union 3 to +infinity. And remember, don't put closed interval at -3 and 3 because they are excluded. The second one is the same. So if I want to do factoring, so x and x, the two numbers, their product is -6 and their sum is 1, +3 and -2. If I solve it, I get x equal -3, x equal 2. So the domain is R minus these two values. On the number line, -infinity to +infinity, -3 first and then 2. The domain can be written as from -infinity to -3, open interval, union -3 to 2, union 2 to +infinity. Even and odd functions, it depends on the definition of even and odd function. If you replace x by -x and nothing changed, then this is even function. If you find out that the function totally multiplied by negative, all the elements has been changed to change the sign, then it is odd. So if we take 59 and replace x by negative x, we're gonna have negative x exponent 2 plus 1, simplify negative x over x to the power 2 plus 1, and it can be like negative x over x2 plus 1, which is the same as negative f of x. So this is odd. If we take 61 x over x plus 1, so replace x by negative x, we're gonna have negative x plus 1, simplify it, negative x plus 1, it can't be done as negative x over x plus 1, and it's not the same as the function itself, so this is neither. Some other technique is I multiply it by negative. So if I multiply by negative, fraction, we don't multiply up and down, we just multiply one of them. So I prefer to multiply the one up by negative. If you compare it with the function itself, you're not gonna find it the same. So that's why it's neither. 63. X squared minus x4. Replace x by negative x, we're gonna have 1 plus 3 negative x exponent 2 minus open bracket negative x to the power 4. Simplify it, 1 plus 3 and negative x to the power of 2 is positive, so 3x squared, negative outside, and negative x to the power 4, it is positive x to the power 4. Comparing with the main function, I find it's the same, so this is even.